Hi, in this video we're going to use trigonometry to find unknown angles in a right angled triangle. Now, in the previous skill we saw how we can use trigonometry to find unknown lengths. And the way we did it is we initially labelled the sides of the triangle relative to the angle of interest. So the angle of interest here is the y. The angle of interest in a right angled triangle is not the right angle, it's just the labelled angle here. And then we're involving two of the sides. So we can see that we've got this side of 7 centimetres and this side of 9 centimetres. And remember what we did? We labelled the sides relative to this angle of interest. So this longest side of the triangle is known as the hypotenuse. The hypotenuse. And I put a little h for short in a circle. And then this side here of the 7 centimetres, this side can be seen as opposite the angle of interest, and this is called the opposite length. And I put a little O for short. Now, we didn't use the other side here because it's not labelled, but this is called the adjacent because it's adjacent next to this angle of interest. And then what we did is we used one of our trigonometric ratios. So we use either sine, cos, or tan. And what these are their kind of magic functions which take the angle of interest as the input. This is theta. Theta is just the angle of interest. Theta is just a Greek letter that's often used as a variable for angles. So don't be upset about the fact we're using Greek here. And then it gives you the relative size of two of the sides of the right angled triangle. Now, notice here, for example, we are using the opposite and the hypotenuse. Which three of these uses O and H? Well, it's the first one here. We can see that involves the O and the H. So what we're going to do is we're going to write out that formula. And then we're going to substitute what we have in our diagram. So we've got the O and the H, and the theta is this angle of interest here. So we've got sine of theta. Sine of theta here is y. And that is equal to the opposite, which is 7 centimetres, over the hypotenuse, which is 9. And we get this. Now, in the previous skill, when we were finding unknown lengths, it was one of these lengths here that was unknown. But this time, it's the angle theta that's unknown. Now, we need to solve this equation to find y. But in front of this y, we've got this sine here. How do you get rid of it? Now, thankfully, we've got something that undoes sine, cos, and tan. And these are called inverse trigonometric functions. So what we actually do is we do the inverse sine of both sides. And it's written sine with a little -1 like that. So we do inverse sine of both sides. And basically, this will cancel out this sign here. It's a bit like if something you had added 3 to it and you want to get rid of the add 3, you do the opposite, the inverse, you subtract 3. So if you've got sine of y, to do the opposite, to undo the sign, you do the inverse sign, written like this. So if we do the inverse sign of the left-hand side, it cancels out this sign, just leaving y here. And then the right-hand side, we're going to do inverse sine, sine -1, we write it as of 7 over 9. Now, to get inverse sine on your calculator, you just need to press shift and then sine, or your model might work differently. So I'm going to do shift sine of 7/9, and that's going to give me 51.1 degree. And does that look right? 51.1 degree, because it's this angle here. Well, yeah, that looks about vaguely right. I know it's not drawn accurately, but that does seem like a sensible answer. And we're done.